specifically, hopefully, to serve the operational mission of the National Water Center. And so, like Zach said, I am a remote sensing analyst, and I'm helping get the water node off the ground by serving as the operations manager for the water node. Just a little bit about me. I began my scientific career as an experimental fluvial geomorphologist. So during these experiments, a lot of times acquiring and processing, very large amounts of imagery. And that's kind of how I got into image processing. Then in graduate school, I had my first remote sensing project, and that was looking at dune deformation in White Sands, New Mexico, and how vegetation affects the way dunes deform. That's me and some other fellow workers in White Sands. And now I'm here at CIROH and working to apply my background in fluvial processes and remote sensing to help try to serve the general public. So the water node is part of NOAA's CoastWatch program. And so I just want to try to explain a little bit about what CoastWatch is. And so the whole goal of CoastWatch is to try to create a value-added service on top of the satellite data that they disseminate. And so it's, in CoastWatch's view, it's not really enough to just throw up, terabytes or petabytes of satellite imagery onto a website and then say, okay, well, you have the data now, you can do everything. CoastWatch is there to try to help people that might not necessarily have a remote sensing background but still want to use this data in their research, be able to use the data. And so, the philosophy is make the data available, but then also, essentially provide a higher touch service along with that data to help train people and make the data a bit more approachable and more accessible. And so there are about kind of 4 pillars to CoastWatch, I suppose. If we look at this central diagram, there's CoastWatch Central, and so they are housed inside of the NESDIS line office, and they help these regional and thematic nodes, of which the water node is one, process and disseminate data. There are a third pillar is these applications and research teams. So there are 4 research teams. There are about 20 scientists spread out among these teams, and that their purpose is to conduct research relevant to the mission of CoastWatch Central and these various nodes. And then CoastWatch also has quite a significant training and outreach effort, as I mentioned previously. So there are about 7 or 8 of these nodes. Yeah, 7 with this new water node. Most of the nodes are regional. So there's a node that's just focused on the Great Lakes and developing and disseminating products related to the Great Lakes. There's a node for the East Coast. There's a node for the Gulf of Mexico and Caribbean. There's a Gulf for the Central Pacific, so like Hawaii, Alaska, American Samoa. The water node is thematic, and so it's a new thematic node where it's not a specific region of the country. It's more, okay, let's try and create and disseminate remote sensing data sets relevant to inland streams and inland lakes. So here's just a, kind of for you guys to get a bird's eye view of where both the National Water Center and CoastWatch are within NOAA. So NOAA has 6 main line offices. And so the National Weather Service is one line office, National Ocean Service, Fisheries, and then NESDIS is another line office. And so NOAA has an entire line office just dedicated to basically satellites and satellite imagery. And within NESDIS, there are 8 program offices. And one of those program offices is called the Center for Satellite Applications and Research, or STAR. And CoastWatch is an organization inside of STAR. And so CoastWatch Central is housed within STAR, but then these regional and thematic nodes are actually usually housed within other line offices. So if we go back to this map, the East Coast node is inside the National Ocean Services. The Great Lakes node is in the Office of Oceanic and Atmospheric Research. Polar Watch is in National Marine Fisheries. And so the water node is actually housed inside of the Weather Service. And so it's a way for NOAA to kind of break down some organizational barriers and encourage, intra-organizational collaboration. Hello?
Yeah.
Okay, so why the water node? So essentially, the National Water Center thought the water node would be a good idea because to provide forecasts, the National Water Center relies on models. And right now, the National Water Model is honestly a bit data starved. There's over 3 million miles of reach. And hello? Is there a question? And there's only, a very limited number of gauges, a couple thousand gauges. And so there's a high probability that those models could be improved by increasing the quantity and variety of data the models can ingest. And so this has led the Water Center to think, okay, well, it'd be great if we could get more remote sensing data into the model, assimilate more remote sensing data. And one of the first ways they thought of doing that was to work with NOAA CoastWatch. And so the Water Center and CoastWatch came together to create the water node. And the hope is that the water node will be a vital part of the Water Center's research to operations infrastructure. So yes, here's a diagram showing that, right, where you have all these researchers within CIROH, right, and then the water node kind of acting as a means for those researchers to understand the needs of the Water Center, the Office of Water Prediction, and NOAA more generally, and basically help scale research into operations and make that research directly relevant to operations. And so one of the big, aspects of all the CoastWatch nodes and also the water node, right, is that as much as possible, we want to make the data that we're feeding into the model and the data that we're disseminating to the public the same thing. And we also want to make that data as open as possible. And so, why would we do that? And I am going to make the argument here that when you make your data open, essentially the entire community, it's very similar, right, to the argument for open source software. The entire community can come together, think about the data, discuss it, inspect it, and increase its robustness and quality. And then ultimately, that improved data manifests itself as, an improved water model, an improved data being fed into the water model. So here, this is supposed to be, so we're working on a prototype website right now. The website can be found at waternode.ciroh.org. still working on getting a publicly recognized security certificate, so you have to click on the proceed anyway. But it is safe, but not publicly safe at the moment. The code for the website is being housed at this repository here. The water node is one of many services and tools CIROH is building out. If you go to docs.CIROH.org, you can see more services and tools. So we're interacting with, in this video, we can be interacting with the spreader. So here we can zoom in, and we're going to see a flood map created by Team Star. I think this one's mostly cloud covered, but this is just to demonstrate some initial functionality. And so where do we want to be in the near future? And so essentially, we want to be ingesting a variety of different data sources. Those could be either from servers that are making their data publicly available, from data being housed on an AWS bucket within CIROH, or data being housed in other parts of NOAA on AWS or on another cloud. We're going to then catalog that data inside of a spatiotemporal asset catalog or stack catalog. And then that catalog is going to be ingested by that graphical client that we just looked at in the video called Stack Browser. You'll be able to access that client from the water node landing page. And then ideally in the near term, we're also going to be adding a bunch of tutorials. One of the nice things about using stack catalogs is that this Stack Browser graphical client isn't the only client. There's lots of clients for interacting with stack catalogs. So the idea would be to have these tutorials, and then these tutorials would link out to a Jupyter environment, either hosted by CIROH or maybe some place like Quasi or even Colabs, and basically then just demonstrating, okay, well, here's how you would start to work with the data being cataloged and or hosted by the water node. While we do want to make as much of the data as possible public, there will be some data that will require authorization to access, especially when we are prototyping data products that are being developed within NESDIS. And so we're also going to be adding the capability to restrict access to some of the data sets in the near term as well. And I'd also like to thank Benjamin Lee and Arpita. I know Ben's on the call, hopefully Arpita is, for all their help with so far with developing the prototype, and also their help going forward. And Adam Warnock, he's the one that helped me develop the homepage that you saw. So he did most of the work on the homepage. Okay, and so I mentioned these spatiotemporal asset catalogs. What is Stack? And so Stack is a mature, standardized way of interacting with geospatial data, searching through it, updating it. One of the benefits of buying into this standardization is that once you do, you can then use the same tools that you would use to access the water node data to access data being provided to you from Microsoft's new planetary computer environment, from other people within NOAA, from USGS. There are European agencies that are already using Stack. And so the Stack spec allows you to, I guess, buy into this growing ecosystem of tooling and services that all kind of speak this specification. And so I now want to talk to you and also hopefully engage you in a discussion about potential prototype services that we've been thinking about that the water node could provide. The first one is this FIM evaluation. And so the idea is that whenever we do have a remotely sensed flood map, it would be great if we could immediately make that accessible to water center operations and have it co-located with the flood extents that are computed by the water center's own flood inundation models. And so, the idea is you would have a tool that would have, okay, here's whatever remotely sensed flood map we have available for this event. Here's the modeled extent at that time period, and here was the discharge estimate. And then you can then, hopefully use this tool to also explore some evaluation metrics. And then water operations could use that, eventually CIROH researchers and also other stakeholders like emergency responders or the general public. So here would be an example of one of these evaluation tools. This is the GVAL tool that's being developed by Fernando Aristizabal at the Water Center. And so the goal would be, okay, here is basically a map showing the level of agreement between a remotely sensed flood map created from SAR imagery and a flood map created using the water center's height above nearest drainage relative elevation model. And so here in this beige color, you see complete agreement between the two maps. And green is where only the map says there's water, and the pink is where the modeled extent says there's water, but the remotely sensed map says there's no water. And like I said, also, once you have these kind of agreement maps or some other way to start more quantitatively assessing agreement, you can also start to develop metrics as well. So here would be, a table of just literally just the count, the total sum of how many pixels fall into each of those categories that I just described. Another service that I think would be interesting for the water node to provide and would be catchment average quantities. So basically, for a given catchment, say providing time series of soil moisture or trends in land cover usage, like trends in vegetation, maybe estimates of net evapotranspiration. These would probably be what we could provide initially very quickly. In the future, we could also provide estimates of average snow cover in a catchment, soil type, and also, Steve and I definitely want to pick the community within CIROH's brains, right, and say, okay, well, what would you guys actually find useful, or what do you think would be useful for operations? And another service that we've talked about are creating remotely sensed data sets of channel measurements. And so with the launch of the SWAT mission and with other currently running altimeters, this should be possible. And so essentially trying to compile for the larger streams in CONUS a data set of slope, water levels, just more generally, width, and inundated width. And the idea would be that these would have the potential to inform out-of-gauge rating curves and also help us create better parameterizations of channel cross sections and also things like bottom friction. Another service that we've talked about is downscaling and tagging DEMs. And so essentially, right, this problem of using the best possible DEM for the water center's modeling effort is something that operations is already on operations' mind. And so we definitely want to explore ways that we could potentially improve the DEMs that they're using. And so, there's been recent work on these AI-enabled super resolution techniques for DEMs. One of the current problems they have is, the DEM they use for their flood inundation mapping, a lot of the times will say that a bridge like this or a bridge like this is inundated when it's actually not. So maybe there's a way that the water node could develop essentially like just a geotagging approach to areas that are likely to be problematic for their current models. Another thing we've been talking about is water quality. And so, turbidity could be one of the first targets to start to provide data sets that, give people ideas of water quality in different areas. So this is already a capability of one of the CoastWatch science teams that I was telling you about earlier. And so this is a picture that I got from one of their teams. So this is using ESA's PlanetScope data from there to estimate the suspended particulate matter in an inlet during, I think, Hurricane Ivan. But the idea would be that we could also do this for larger streams and also for large inland lakes. And I'd also like to pause for a minute or two, not too long, but if anyone has other ideas that they think, okay, well, this should be a top priority for the water node, feel free to email me at dylan.lee@noaa.gov. If someone has a very idea, you can also just start talking right now. Feel free to raise your hand. Maybe wait like 10, 20 seconds. All right. Yes, so I will definitely be monitoring this email address, and I would love to have a conversation with anyone that has essentially additional ideas for the ways that they think the water center's models could be using remote sensing data better. And so, like I said, the other big pillar of the nodes within CoastWatch is education and training. And so they take this mission very seriously, and this is definitely going to be a big part of the water nodes mission. And so they have, if you go to CoastWatch Central's website, they have a learning portal. They have videos that they've created. They have tutorials for the software tools that they make available for working with satellite imagery. They also have classes, and so they have this CoastWatch satellite course. It has been offered in the past as a short course or a semester-long course, and Steve and I are very excited about the possibility of essentially adapting the course material that the other nodes have already created to create a water node specific educational short course for working with remote sensing imagery. And so here's an example of some of the educational resources that have already been developed by CIROH researchers or the water node. And so the idea would essentially be to add these in because a lot of the current course material is very focused on working with ocean data. The water node is already involved in education outreach, and so as operations manager, one of the things I've been doing for the past 10 weeks is working very closely with an undergraduate that was participating in CIROH's RAU program. Oh, Steve wanted me to remind you guys that all of this is very new, and so I'm building it all from the ground up. And so, when I talk about developing these materials, it is very much a incipient effort, and so I think it's really exciting in a way because it also means that all of you, if you do have some ideas and you have, I guess, some opinions or thoughts on how the water node should progress, you can definitely reach out to me. And I think research within CIROH, we definitely want you guys to have an active involvement and an active hand, I guess, in the progression and development of this new effort. So with that in mind, one of the ways we're going to try and do that and to engage both the CIROH community and the community within the National Water Center, I guess I'm going to aim for about every month or two, try to host a kind of podcast-like thing called Watercast. And that would be a way to bring CIROH researchers together with Water Center personnel so that they could each understand each other's needs and perspective and try to, I guess, align a bit more on, okay, well, how are we actually going to make research operations happen? And so some first topics for Watercast that we've brainstormed, Steve and I, are film validation and comparison, these remotely sensed channel morphology measurements I was talking about earlier, trying to develop that data set. River ice, so the Water Center already has a river ice product that they produce, and so maybe we can talk about ways to improve that or ways to, I guess, scale up what water operations is already doing, or new techniques, new approaches. Measuring inland water temperature. So this is once again in line with the idea that the water node does eventually want to increase the amount of water quality data that it's making available. And one of the first targets are, turbidity, and then also water temperature is another one I think we could start thinking about in kind of the medium term. Remotely sensed snow water equivalent. So let's start about, okay, ways that the water node can help with remotely sensed snow data. And then also this idea of, okay, well, how useful would remotely sensed catchment characteristics be? So trying to make available time series of these catchment averages of, say, net or soil moisture. If you have an idea or you would like to be a guest, please also once again reach out to me at dylan.lee@noaa.gov, and I'd be more than happy to talk to you about any ideas that you have. So in conclusion, the water node is once again just getting started, but the hope of all of us within CIROH and the Water Center is that it will grow into a collaborative nexus for the experts, the satellite imagery experts within NOAA, the National Water Center, and CIROH to all come together to work on ways that the next generation national water model can use remote sensing data in a better way. And one of the great things about being able to work inside this CoastWatch framework is that CIROH and the Water Center can now tap into an established framework and web of relationships with decades of experience. And so, I definitely don't think that's something that should be underestimated. And yeah, so I would definitely like to once again emphasize that the water node wants to help research within CIROH communicate with Water Center operations. And we want to help actually make this R2O pipeline a reality. And with that, I'll take questions. Yes, Alan Mayu.
Hello, Mayo. Thanks for the great presentation. Great work in this short time span. So a couple of questions. So the first thing is, so I want to go back to the test portal that you've developed. It looks great. And one of my question is, there's already some existing open satellite data, be it Amazon AWS and Google Earth Engine Cloud Computing API, where USGS and NASA, all other NOAA data exists on the catalog. Is there an overlap with that? Are you connecting with those APIs, or this is just a standalone data catalog access. And then my second question related to that is, you mentioned some of the potential use case with NextGen project is to summarize catchment-based data set such as vegetation indices and soil moisture, whatnot, at the catchment level. Does the portal have a computational element, something like you have in the Google Earth engine? You run analysis on using the API and then generate results, or I just want to know more about that. Thank you.
Yeah, great questions. So once again, I would like to go back to this idea of that the idea behind CoastWatch is much more to add this human element to the data. And so the idea, right, is that not only will the data be available, but also you could email me essentially and say, oh, I have this specific question about this data set. And then I would try my best to get back to you within a quick time and try to essentially help you work with the data. One of the good things about going with this stack catalog, right, is that it will allow us to essentially add additional information and additional metadata to a lot of publicly available satellite data sets that are already out there, right? And so, yeah, you're right. Microsoft's planetary computer is already going to make a lot of imagery publicly available. I could foresee, right, one of the cool things the WaterNode doing, right, is essentially just linking out through the WaterNode catalog to imagery, but adding essentially metadata that's been customized to the needs of hydrologists, to the needs of CIROH researchers, and to the needs of the water center. In terms of the currently planned computational capabilities, so the WaterNode, say for the catchment averages, right, the WaterNode would be using its own computational resources to create those catchment averages and then host that data. But then it would, if in terms of actually then working with those catchment averages, I think it would be, it would fall onto the user to then provide the additional resources to manipulate that time series data. But I do think there will be an element where we essentially help you get started, right? And so this is what I'm trying to get at with Jupyter environments, right? And so making notebooks available that say, okay, well, say you want to query, 2 years of vegetation cover in, the Delaware River Basin. Here's a notebook on you how to do that, and then, maybe bring in, data from planetary computer and link changes in land cover to, changes in pervious surfaces or something like that. And so this and link out to, notebooks that the user can run on an environment that might end up being hosted by CIROH. But like I said, it could also just be, okay, these notebooks are hosted on a resource that has relatively limited computational power. We help you get started. And then if you want to do a large scale analysis, you then have to figure out how to, I guess, access a heftier computer. So Steve says, do I have plans for ways the WaterNode will help CIROH researchers connect to other CoastWatch nodes through you? That's a good question. So I should definitely add a link in the About section on the WaterNode website to the other nodes. And I think, the first step is just being aware that these services exist, right? And that, say, if you do email the Gulf Coast and Caribbean node about, say, you're looking at something in the nearshore or something about an estuary, that they actually will email you back. And I've already started developing relationships with the other managers of these nodes and with CoastWatch Central. And so, we can explore ways to create, I guess, more structured access. But I would say that as a first pass, if you already have a data set in mind being provided by the other nodes, I've already met these people, and so I also would have no problem helping you reach out to them. And the other nodes are much more mature. CoastWatch has been going since the late 80s, like 1988 or 1989. And they do have a lot of data sets on their servers that are actually, almost all of them are freely available to download. The main thing to keep in mind with that, right, is it's almost all ocean data or coastal data. The Great Lakes node does have a lot of data on the Great Lakes. So they have like the surface temperature of the lakes, time series about that. They might have some turbidity data, but they also all have their own node websites that you can go and explore the data sets that they have available as well. Are there any other questions? All right, well, like I said, feel free to reach out to me, and I will, hopefully be hearing from some of you, because I definitely, need to come up with some guests for this Watercast podcast that we're going to be creating. And if not, I guess some of you will be hearing from me, because I'll be chasing you down. Well, okay, and with that, I guess I will hand it back over to Zach.
Thank you, Dylan, and thank you everyone who joined and asked questions. I think we learned a lot today, and we continue to learn a lot about the research to operations pipeline and needs and why we're all here in the first place. So I look forward to seeing you all for the next webinar on August 17th. We'll send out a save the date right after this. Head to our social medias at noon, try out the Tuesday trivia question, and enjoy the rest of your day. Thank you.